Hello everyone. Today we are going to solve second add two numbers link lead code problem. In this problem, we are given a two linked list L1 and L2, and we have to return the sum of those two linked list nodes. And as seen over here, example number one, we have given a two linked list 2, 4, and 3, and second linked list is 5, 6, and 4. We have to sum of those two linked lists and return those linked lists. So as seen over here, in first node 2 and 5, sum is equal to 7. In second node 4 plus 6 equal to 10. So we will store 0 and carry to the next element. Same for 3, 4 equal to 8. So we will store 8. So this is the problem statement. Let's take another example. 9, 9, 9, 9, 9, 9, 9, 9, and over here also. So we have to, this is the first linked list, this is the second, and we have to return third linked list. So what we're gonna do is 9 plus 9 equal to 18. So we will store it, carry to the next. Again, 9 plus 9 plus 1 is equal to 19. So we will store 9 and move carry forward to the next node. Again, 9, 19, store 9, carry to the next. Again 19, store 9, carry to the next. Over here we can see that there is no node over here, so we will assume there is a 0 over here. So 0 plus 9 plus 1 equal to 10. So we will store 0 and carry goes to next node. So again there is no element in linked list 2, so we will assume 0 and sum of 9 plus 0 plus 1 equal to 10. So again 0 and 1. Same for here, 10, 0 carry to the 1. Uh, Now there is no node over here, there is no node over here. So but carry is there. So what we are gonna do is assume 0 and 0, and then 0 plus 0 plus 1 equal to 1. So we will return the this. So this is the problem statement. So to solve this problem statement, uh, let's take first example. 2, 4, 3, 5, 6, and 4. So what we are gonna do is we first of all get this number, and the carry, and we will sum up this in a d d variable. So first of all, there is no carry, so we will assign carry equal to 0, and then we will iterate through the loop while L1 or L2 or carry. Is carry remaining? Is there any carry remaining? So we have to iterate through the array. So over here, there is one carry remaining, so we have to add those carry. That's why we add carry over here. Now we will get d1 is equal to L1 dot val. So we will get this value to d2 equal to L2 dot val. We will get this value. Now we will sum up this value. D is equal to d1 plus d2. So we will get the value of these two elements. Now we have to modify the but there is one problem over here, that we didn't add carry. If we there is any carry, so if there is previously any carry is remaining, so we have to add also. So that's why we have to must add the carry over here. This is the problem so many programmers make. So just be point on your mind. So we have to add carry. Now we have to rewrite this carry. Is there any carry over here or not? So for that we have to divide this number by 10. Integer, we have to do integer division. So d integer division by 10 is equal to uh, our carry. So how this will gonna happen? So let's take assume a number 12. 12 divided by 10 is equal to integer division. This is the integer division. So we will get 1. This value is removed. For 9, 9 divided by 10 is equal to 0. This is the integer division. So we will eventually get carry. And we will again rewrite this d. And why we will rewrite this d? Because d, uh, maybe d is greater than 10. So if d is greater than 10, then we don't want a 1. We only want last element like 0, 1, 2, 3, 4, 5. We want only these numbers. So that's why we d modulo 10. So we will get last digit, last element. And we have to write in this order, carry and division, because if we write uh, before this carry, then d value will change and we are not able to find carry, appropriate carry. So every time we have to write this statement at the after the carry. We have to write this statement after the carry. Now let's assign the value, create. So over here we will create a new linked list like L3 is equal to list node 0, and we will assign L3 dot next equal to uh, list node well d value, and then we will go to the next L3 dot next. This is the pretty simple code, isn't it? But uh, this is take uh, this code has a times complexity of n, a space complexity of big of n, and time complexity also is big of n. So we are not able to reduce the time complexity, but yeah, we can reduce the space complexity. And by how? If we store these values in a linked list 1, is there any way? So we can store these values in a linked list 1. So that's why we are not able to uh, use extra space. We will return the just L1, and we are not using the third linked list. This is, and what we for that what we will gonna do is, let me change this color first. Okay. Then what we will gonna do is simply just over here we will change the sentence L1 dot well equal to uh, D. So by changing this statement, we will we will reduce the space complexity big of n to big of 1 in a constant. But there is some problem in this approach. While we are solving this, maybe there is linked list which 1, 2, 3 and 1, 2, 3, 4, 5. Maybe uh, there is some linked list which doesn't have any values, any nodes over here. Like this, there is no node over here. So for that case, what we will gonna do is we will just swap the values like this. We will this is the 3 node. In the next we will change the none to assign next node of values. Like we will change the address of next node. So in this value, v has now pointing to the fourth, and then 5 and 6, and we will change this 3 to none. By using this, we extend our linked list L1 and uh, reduce our linked list L2. So by using this technique, we can reduce the time complexities into big of 1. So we have to just simply change the address where the next element is none, and change to the another L2's linked list address. This is the pretty simple way, isn't it? Now let's write a code. Now let's write some code. So first of all, I will create a two head one and head 2 and assign it L1 and L2. Head 1 and head 2 is used to iterate through the loop, and we will also create a previous which track down a previous node of our current node. And initially H1 and H2 are pointing to the first node, so previously is equal to none, and then we assign the carry is equal to 0 because firstly carry is 0. We will iterate through while L1 or L2 L sorry while H1 has nodes or H2 has node, and we will get the value of H1 node, H1 dot val, and D2 is equal to H2 dot val, and we will create get the value of D using D1 plus D2 plus also carry. We have to add carry also over here, and then we will assign a carry is equal to D integer division by 10, and then our D value is equal to D percentage 10. So by using this we have to write this in this format, this two, because if we write this this statement before carry statement, then D value will change and we will not able to find a carry. So that's why we have to write in this order. Okay, and then we will assign L1 dot val sorry H1 dot val equal to D. So this is the pretty simple way. Now we will move to the next. H1 is equal to H1 dot next, and H2 equal to H2 dot next. But wait a second. There is uh, there is case where H1 and H2 are none. So what we will gonna do? So for that we will check if H1 dot next is exist or not. H1 is none or not. If H1 is none, uh, H1 is not null, then we will go to next. Otherwise, we will assign none. If same for the H2, okay. And I think this will happen to the D1 and D2 value also, because if H1 is not exist, so how we assign the value? Then we will check if H1 has value, else we will assign 0 as we discussed in the video. H2 else 0, and this is the pretty simple code. But before assigning a value over here, uh, we have if I have shown you one example in this. I have shown you an example where L1 is small and L2 is long. So for handling that case, we will check if uh, previous dot next is null. If previous dot next is equal to null, and over here we will assign previous equal to previous dot next. We will go to the previous assign this previous value equal to h1. Okay, and then we going to next. Then we will iterate to the next. Matlab, means we are tracking the previous node of current node using this previous variable. Now we check whether the previous dot next is null or not. If previous dot next is equal to null, then we will simply do is previous dot next equal to h2, and then h1 is equal to h2, and h2 is equal to none. So by using these three sentences, we making our linked list first linked list size is bigger and second linked list size is smaller. And after end, if we are checking if carries exist or not, if carry is there, then we simply previous dot next is equal to waste node of 1. We will make the previous dot value of 1 and then simply return L1. So this is the pretty simple code over here. I will just run for it's passing so all the cases or not. Okay, I made a writing mistake, compilation error. Okay, I am previous is equal to null, so we have to write h1. Sorry for that. And let's again run this program and try to submit this program. Okay, submitted, looking good. So this is our program. Thank you for watching this video.